I'm happy to share that this particular course received overwhelming response. We received more than 8,000 course participants who are attending this particular course across length and breadth of the country. So thank you all, dear participants. Today I am going to talk on such a emerging technological approach which is revolutionizing agriculture. India witnessed widespread development in agriculture, and one of them is space technology and geoinformatics and its application in achieving food security and sustainable development. That is only achieved through climate smart agriculture. So this is one of the widely used term in agriculture sector for smart farming. There are certain issues and challenges what we have faced over the period of last 1 century. Some of them are is like increasing CO2 concentration, which is causing warming in the order of 2 to 2.5 degree in the last century. There is an increase in GHG emission also. So this GHG emission, which has increased from 0.4 to 1 gigaton carbon. There is a depletion of the natural resources, mainly biodiversity loss. Agriculture water use also tremendously increase, and which is expected to increase by 18% by 2050 to maintain agriculture production. On the other side, deforestation rate has also tremendously increased, species loss happening. Then also there are glaciers and snow, which are the water tower for the downstream agriculture. They are melting. And there is also sea level rise, which is affecting substantially coastal agriculture. All this finally causing issue of how to ascertain food security, water security, environmental security, and also finally achieve sustainable development goal. So one of them to address is the space technology, or you can say geoinformation. Food security is at stake these days because of several depletion of natural resources, mainly land and water, and also other factor which is causing large scale declining of resources. So mainly we need to have a food supply double in the by 2050. Further, there is no scope of expansion of wasteland. We have already brought whatever wasteland was there under agriculture. So further expansion may eat up our natural ecosystem like wetland, grassland, or forest. On the other side, also climate change, which is a threatening almost every country and intensifying imbalance in the food supply. Food security critically depends on water, and water scarcity is posing a serious challenge. Agriculture production, that is why need to be more intensified in a sustainable way through adoption of innovative and emerging approach like climate smart agriculture. If we see in the back, particularly recently concluded years like 2021, which was largely affected by climate crisis. So India witnessed more than 35 million hectares crop loss in 2021. Terrible year for the whole world due to large scale and widespread frequency of extreme weather event that imposes different kind of effect across the world. Mainly cyclone Tarukene, cyclone Yes, which has created havoc in the West Bengal, Karnataka, and Odisha. Even in 2021, there are some reports that wheat production drastically declined by 40% in US. Russia, also one of the strong exporter of wheat, also noticed unfavorable weather condition which causes decline in wheat export. Even in India, our tomato prices, which has also soared to a different height or roof, touched the roof in November end of the 2020 in wake of unseasonal rain or devastating rain. So these are the all recent effect of the climate crisis, or due to, okay, you can say it is a maybe because of climate change also. So, but here I want to highlight that it is not like that only India. India is not only polluting the atmosphere. India is far behind. So only those countries which are polluting less or which are contributing less in greenhouse gases are most affected by climate change. So I want to say that India or other developing countries, they are having per capita CO2 emission is very less, but effect of this greenhouse gas rise and the climate change is drastic in case of these developing countries. But on the other hand, developed countries like US, Russia, China, which has got higher capita emission, CO2 emission, but effect of this climate change is relatively less. So to overcome all those things, we need to develop a kind of agriculture which can sustain in a longer term. So one of the most intelligent and technological approach is climate smart agriculture. So climate smart agriculture is nothing but it helps to guide action, transform agriculture and food system to green and climate resilient practice. In another way, we can say it is an integrated approaches to address this interlinkage of food security and climate change. Other way, we can also coin it is an approach to help people who manage agriculture and food system to respond effectively against the climate change. Also, World Bank also coined one definition of climate smart agriculture as an integrated approach to managing landscape to help adopt agriculture method, livestock and crops to the effect of climate change and where possible. So this is the in generally it is all about the novel approach that can transform agriculture to more climate resilient practice, climate resilient system or food secure system. So background, if you see climate smart agriculture, it is a one of the important component of India and G20 countries sustainable development goal set for the 2030. It is quite complex and massive challenge. This approach has got triple advantage, or you can say triple objective. First, sustainably increasing productivity and agriculture income, adaptation to climate change, and reduction of the greenhouse gases. These are the triple objective of the climate smart agriculture. But in India and other developing countries, as we know, majority of people lives in India, rural India, and agriculture is the main source of their income. So development of or improving productivity of this in rural India, we need to increase productivity of small farmer, livestock, fisheries as well as forest production to achieve food security. At the same time, climate change, which is also threatening all across the world, particularly developing countries, are most widely affected. There is a change in temperature, precipitation, increasing in frequency of drought, flood, heat wave event. There is also sea level rise. All this leading to the devastating effect. So we need to have a resilience mechanism, and which needs to be a top priority. Agriculture is also a source of greenhouse gases. As 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 of now, agriculture in the world contributes around 10 to 12% of total greenhouse gas emission. In India, it is around 21% of total greenhouse gases emission caused by agriculture. So mitigation of these greenhouse gases and which is leading to the climate change or warming need to be done at the earliest. For that, to strengthen, we need to have a certain action to strengthen adaptation and enhance food security, thus mitigating action compatible with the national priorities for the agriculture. So here you can see the one chart that shows which are the different indicator of the climate smart agriculture. So it has got three pillars: productivity, means food security; adaptation or resilience; and third is a mitigation. So productivity you can do enhance by sustainably increasing productivity and income. You need to increase crop yield, biomass, or food secure period. For achieving resilience or adaptation, we need to build resilience of the people as well as food system, including livestock, against climate change. This can be done by increasing efficiency of rainfall, yield stability, and agriculture income. Third is a mitigation of greenhouse gases or climate change, mitigation of climate change. That can be achieved only through reduction of greenhouse gases or removing greenhouse gases by some sequestration mechanism. So there is a greenhouse gas fluxes increasing in the carbon sequestration through increasing above ground biomass or terrestrial carbon sequestration, then storing more and more carbon in the soil. So we need to enhance kind of technology, agriculture technology, that improve carbon sequestration from atmosphere and directly fix them into the soil. So in detail, if we see how it is affecting the different dimension of the agriculture and finally achieving climate smart agriculture. So from productive point of view, there is a crop type or cropping system which has got significant importance with respect to increasing crop yield, reduction of risk due to water or wind erosion, and enhancing in soil fertility. Water use is also quite important with respect to productivity because food security and water availability is closely linked. For enhancing water use, we need to increase irrigated area, reduction in the water withdrawal, and improve water productivity, means water use efficiency. Also energy, reduction in the electricity, mainly coal based electricity, we need to reduce. Instead of that, we need to increase use of renewable source of energy like wind and solar. Resilience can also be tackled through increasing stability of production, promoting income and site specific knowledge. So particularly cropping system, we have to develop a kind of crops or cropping system which are more resilient or more resistant to the drought. Similarly, livestock. This day, earth observation technology has been used for the disease informatics, animal health, and so on. So we can also improve how livestock or breeding of the livestock that which have got more coping capacity with respect to the arid drought and aridity condition. Mitigation mainly refers to the reduction of the emission of greenhouse gases, then sequestration of the carbon either through terrestrial cultivation like terrestrial biomass, increasing terrestrial biomass through growing of the crops like high biomass crops or grasses or forest based terrestrial carbon sequestration, we can avoid this reduced greenhouse gas mitigation. So from viewpoint of adaptation now, which is a critical component of the climate smart agriculture. Now here you see that yellow color, orange, blue and purple all are with respect to the particular kind of auto adaptation mechanism. So change in input Orange color, that is related to manure, fertilizer and mulching. These are the things which you can improve nutrient use efficiency, fertility, and also to certain extent water use or water storage. Crop type, which is one of the most important adaptation strategy adopted by the farmers. So right kind of crop cultivar which has got resilience mechanism, resistance or tolerance or drought escape mechanism, high value fruit trees crop or crop diversification. These are the different kind of adaptation strategy with respect to the crop diversification and crop type. Then water management is also one of the significant adaptation mechanism to reduce the resilience, to reduce the response to climate change effect on the crop or agriculture. So it can be done through irrigation, applying irrigation, water harvesting. Similarly, crop management like shade agriculture, agroforestry, regenerative or conservation agriculture, and also changing of planting date, all helpful in achieving adaptation or achieving resilience. And also there is a one mechanism like crop insurance. We are insuring the farmer against any natural calamity. So crop insurance, crop credit and loan, that also ensure farmer against this kind of natural calamities causing large scale losses in the to the farmer. Then livelihood, like livestock, change in the kind of food system, livestock or livelihood for diversification. The farmer can adopt integrated farming system, like he can cultivate within a 1 hectare, he can go for the fish pond, he can go for the horticulture crop, some fodder crops, also some poultry and livestock all together. So he can resist or he can build resilience against the any particular adverse effect of the climate change. So here you can see one example where greenhouse gas reduction and yield increase, marginal yield increase, that can be achieved with the different kind of adaptation strategy in the humid and dry areas. So here you can see particularly agroforestry and tillage and residue management, which is vital particularly for achieving the mitigation of the climate change through reducing greenhouse gas emission or improving more carbon sequestration or reducing less release of the carbon to the atmosphere. Whereas water management, nutrient management, agronomic techniques, they are good for improving productivity of the different crops and achieving food security. So that is the basic difference what we found between the different kind of adaptation mechanism that is employed over humid and dry areas. Now come to our topic, geospatial technology. Geospatial technology, it is not only the satellites, it comprises the global navigation satellite system, GIS and spatial analytics, earth observation, that means satellites, and some novel 3D scanning. So GIS spatial analytics, that covers some data science, artificial intelligence, machine learning, mobile, cloud computing. Global navigation system, like it is very much useful for locating different ground truth and taking certain kind of crop cutting experiment, which is ideal, which is quite essential for the developing yield models and useful for the early warning. Similarly, earth observation, which provide information, actual information about the state of the earth surface, whether it is a vegetation, land, ocean or atmosphere. Scanning, that is useful for lidar, radar, laser scanning. All these are also nowadays very much useful for providing kind of data which is useful for 3D generation, 3D height, 3D generation, 3D biomass generation, canopy height, and many other applications. So geospatial technology has got certain characteristic like earth observation, which has got different kind of partial resolution, temporal resolution and spectral resolution. Partial resolution means ability to resolve on the ground or ability to map minimum area on the ground. Temporal resolution means how frequently an image can be acquired by the satellite for particular area. Similarly, spectral resolution means number of spectral channel, number of bands available within the electromagnetic spectrum. GIS, which is nothing but Geographic Information System, and this is a system which allow you to input, analyze, manipulate and visualize partial and non-partial data. Here partial data means which can be in the form of map or image, whereas non-partial data like crop cutting experiment, weather observatory, radar network and many other things related to the achieving climate smart agriculture. GNSS, that is Global Navigation Satellite System, which is very much useful nowadays with respect to the identifying location of the particular observation, ground observation. Like okay, in NAVIC, one mobile application is developed which can help fishermen to identify the location where fishermen get better catches of fish. So it is directly related to the food security as well as climate smart agriculture. So that way NAVIC and related mobile application has been used by the fishermen for achieving this better fish catch. Similarly, this all technology and can be integrated for making informed decision related to the agriculture. There are dearth of satellites available across by Indian remote sensing satellite with the ground delivery mechanism and diversity of application. So there are satellites available for land, ocean and atmosphere. Land, ocean and atmosphere, all these satellites nowadays very much useful for to tackle various issues related to agriculture. Because now satellites are, agriculture is taking place under open sky. So farmer doesn't have any control, a farmer doesn't have any switch in his hand to switch over to a better climate or better condition. The farmer has to adjust. So we need to have a kind of satellite which can provide advanced and accurate information related to the both crop, soil as well as climate characteristic. So there are satellite like ResourceSat, which is providing useful information related to the crop type, growth, phenology and health. Similarly, we have got one satellite is a reset series. So this reset satellite is nothing but radar based satellite, microwave, active microwave remote sensing. So it has capability to monitor during weather cloudy condition. It is independent of weather condition. It can penetrate through cloud and get information for the farmers. That is why it is useful mainly to monitor crops which are cultivated during Kharif season, particularly rice. Then there is a Saral SCATSAT, OceanSat. Nowadays they have got tremendous potential, particularly for soil moisture, wind vector, wind related information, soil moisture, as well as NDVI, vegetation condition. We can also monitor to certain extent with the OCM related vegetation index. There are many climate weather related satellites also becoming useful, particularly for achieving getting certain information related to weather like wind, temperature, humidity, radiation, rainfall and so on. So this is how this different kind of application the Cartosat, DM, slope, elevation, in situ observation, satellite positioning and all this other information, ground based information, all integrated in a GIS, and finally it can be integrated with the certain kind of process based model also to have a certain kind of application like early warning system for achieving food security, drought monitoring, also you can say other crop insurance and so on. So here this is one, if you can understand that we are talking today about the climate smart agriculture. So we need to have a information which is weather or climate driven information which is useful for the agriculture. So from right beginning from the season or even before season, we need to have a information about the rainfall condition. Nowadays, okay, for sowing in the last month also in June end, everybody was interested, every farmer was interested whether his region or his village is going to get rainfall and how much rainfall is, so he can prepare land for the growing kharif crops. Secondly, once okay first rain is happen, then okay he is also eager to wait for the how much again next spell of rainfall, so he can again use that rainfall for planting rice crop or growing other kind of crop or first irrigation during the germination. So for germination, preparation of land, all those things, farmer need to have a very good information about the weather forecast, weather related information like rainfall and soil moisture. Then during growing season, farmer needs to have information about crop condition, health as well as weather. So weather affect the crop growth and development, mainly temperature. So farmer is interested to know about what is the temperature condition, what will be the rainfall condition, cloudy days or open sky. All information directly affect the crop growth and development. And in the later stage, during the harvesting stage, farmer wants to have information related to infrastructure, logistics, supply chain management. So residual moisture for growing next crop. So throughout the year, throughout the growing season, farmer need to have a information related to weather and climate for taking their different farm operation as well as marketing. So agriculture, which is the one of the major sector receiving major use of remote sensing data. As on today, more than 70% of remote sensing data is being utilized for the agriculture sector, and there are large scale of glimpses of application which are being done and realized for the agriculture sector, beginning from crop acreage estimation, drought, horticulture crop estimation, cropping system analysis, irrigation command area management, soil mapping, pest and disease monitoring, aquaculture, and land monitoring. So all these nowadays, this Earth observation data has been operationally used in updation of the agriculture crop statistic at district level. And for that, there is a specific center. Mahalanobis National Crop Forecast Center is working to provide bulletin on crop statistic as well as natural agriculture drought assessment. So satellite which are operating either in the optical or radar imagery, all are useful in monitoring agriculture, and they are also providing critical information related to the crop growth, health, development, soil moisture, and so on. So how particularly this earth observation data and geospatial technology, they are going to help climate smart agriculture. Climate smart integrated and transformational approach emerged mainly in response to grand challenge, mainly food security and climate change. For sustaining agriculture productivity, we need to enhance resilience to climate change and reduce environmental pollution or greenhouse gases emission, environmental footprint of agriculture. Remote sensing, which is the core of the climate smart agriculture, it provides timely and up-to-date information at the resolution what required for the decision making related to the farm operation or farm condition. So the advancement of remote sensing technology allows collection and information production timely and decision requirement at many scale. It is useful for mapping soil variabilities, weather, water, crop performance. Geospatial technology in combination with the internet guides farmers not only to identify the factor but also provides support in making optimal decision. So this is in totally general importance, but if we see, it has got some 10 core areas where Earth observation has got great utility to provide up-to-date and timely information for the achieving smart agriculture, climate smart agriculture. One of them is a crop monitoring. Satellite imagery is acquired to track or monitor crop health, growth, and productivity over large area. It can assess photosynthetic productivity in terms of vegetation indices and also indicate if there is any departure or anomalies, maybe because of pest, disease, or any nutrients, or nutritional disorder. Similarly, weather forecast or weather prediction. Earth observation data has got immense potential. Particularly, it can foresee or forecast weather changes, particular temperature, rainfall, wind pattern, and so on. So knowledge of this help farmer to plan for sowing, irrigation, and harvesting strategy, which leads to the more precision agriculture. Because if very good forecast, weather forecast with the correct weather forecast with the advance 2 or 3 or 4 days in advance, that can help farmer to decide many things about the sowing, irrigation, harvesting. He can withhold irrigation or apply irrigation depending upon the what is the speed of the wind. Similarly, he can whether supply irrigation or withhold irrigation depending upon if there is a rainfall or there is no rainfall. So this kind of farm based decision farmer can take based on the very accurate weather forecast. Similarly, soil assessment. Earth observation technique can analyze soil fertility, moisture, and other characteristics for to prevent soil degradation and to assess for propose suitable crop for increasing crop yield. Water management is also equally important. Earth observation data as on today have different kind of spectral channel which have ability to provide information related to soil moisture, evapotranspiration, and water quality. This helps farmer to make better decision related to irrigation scheduling, reducing water waste, and optimize water productivity. Climate change monitoring, because climate, as we are talking about climate smart agriculture, so climate change monitoring is equally important. Earth observation aids in understanding and predicting climate fluctuation, climate scenario, generate climate scenario, and enabling development of climate smart strategy. Crop yield, estimating crop yield. Earth observation, when it coupled with the advanced artificial intelligence or the machine learning, can predict yield of the crop well ahead of the crop harvest. Similarly, disease and pest monitoring also these days different signature which are obtained from the satellite imagery can be useful for early detection of the disease and pest and to safeguard the crops. Biomass production, as we have understood that increasing biomass production will increase the terrestrial carbon sequestration and also it is useful for the biofuel energy. So satellite imagery can able to estimate crop biomass, and finally it will help in decision making related to the utility of right crop for the energy production. Precision agriculture, to how precisely we can apply nutrients, irrigation or inputs according to varying crop and soil condition. That is called precision agriculture. Here, Earth observation data contributes significantly by supplying detailed partial information on crop characteristics, soil properties, vegetation health, and other plant indicator like evapotranspiration, soil moisture, and so on. This all helps farmer to tailor appropriate crop management practice within the field, like fertilization, applying pesticides or nutrient, and finally it makes optimized use of the this cost inputs to and also avoid environmental concern. Early warning system is another area nowadays Earth observation, because as on today there are many satellites which has got continuous observation for a decade. So there are satellites which are in orbit for more than 20 years or 30 years. So these large voluminous data now helping to develop early warning system to against the for the natural calamities like flood, drought, and pest. By historical evaluation and developing historical time series, one can develop early warning system and key indicator like vegetation health, water quality, and temperature anomalies. Farmer can receive timely alert and preventive measure to mitigate risk and reduce crop loss. So all these tools and techniques create sustainable and climate smart agriculture practice, balancing the productivity and finally address the environmental issues. So this is almost we have covered, but geo information apart from the earth observation, it has got some key specific area like it is useful for the data collection. It can enables you to collect data both partial and non-partial data on crop, land use, and so on. And these are the data useful for the some decision making and modeling. Partial analysis mainly that helps within the GIS can helps to understand the agriculture system by developing relationship between crop, climate, soil, and also you can have overlay of different kind of moisture, soil moisture, rainfall, and other things to understand what is the risk associated with the specific crop. We can also generate decision support system which aids farmers, researcher, or policymaker in making informed decision. These tools include crop yield modeling, risk assessment, precision agriculture for climate change assessment. So similarly, all these climate change modeling, all those things can be achieved more accuracy with the inclusion of geoinformation technique. So this is a particular area where okay, what are the key technology that enables you to develop smart agriculture is the satellite based imaging, drone, geographic information system, GNSS, IoT, Internet of Things, emerging technologies like modeling, cloud computing, and analytics like artificial intelligence and machine learning. All help farmer monitor farm condition, crop status, water requirement, weather condition, and estimate crop yields in advance. So there are different area like climate and weather modeling, crop modeling, data analytics, remote sensing, and GIS, where all this technology has got tremendous potential to support climate smart agriculture. So for that, there are different kind of application can be developed: climate smart decision making, remote sensing supported agro AIML, in-season crop monitoring, remote sensing based agriculture climate modeling, crop evapotranspiration modeling, remote sensing based crop condition monitoring, irrigation decision support system with integrated use of remote sensing data, assimilation of remote sensing for improving crop models performance, crop yield estimation, precision agriculture, remote sensing based risk management, and livestock and animal health and disease informatics, and so on. So all these applications can be achieved with integrated use of various emerging technology along with the remote sensing and GIS to support climate smart agriculture. So especially particular for smart farming, if we have good quality weather forecast, timely and tailored forecast along with the smart sensing, crop simulation model, all can be helpful to identify the problems, nutrient disorder or pest problems or these, and identify the optimum management strategy to supply, have smart irrigation, smart fertilization, or smart plant protection. So this is the way approach where all technology, it is not only the remote sensing GIS, remote sensing and earth observation data that assimilated either in the model or in the climate model, crop model, or some other smart sensing like drone or other kind of imagery, all together can help to achieve smart farming through smart irrigation, smart fertilization, and smart protection, means smart pest protection. So this particularly already we have discussed. Earth observation deals with the giving information about our mother earth. They are giving accurate information about land, vegetation, and atmosphere and ocean. Using all this data, processing technique, and analytics. This Earth observation can be translated into monitor and understand changes in nature resource and environment. We have discussed the importance of the climate and crop modeling, because apart from the remote sensing GIS, we need to have climate and crop modeling, which is a key component of achieving climate smart agriculture. As climate change happen, its impact will vary with the climate change scenario. Mainly study of climate change in agriculture system can be done by adoption of the either regional climate model or global climate model along with the crop simulation model. So there is a one suite of crop simulation model available, which is called decision support system for agrotechnology transfer. So this is one of the best suite of crop model. More than almost all crops are covered, which are providing models, crop models, physically based crop model to provide decision related to the appropriate management strategy, climate change response, and generating climate resilient agriculture. Climate model mainly like WRF, RACE CM, ETA, and mesoscale MM5. There are many regional scale climate models are there. These all models have ability to generate future climate data. So this is climate data are very much essential for predicting prospective crop productivity, crop water requirement, and estimating crop nitrogen status in advance for climate smart agriculture or helping farmers to achieve higher productivity. So in India, there is one center, Mahalanobis National Forecast Center, which is providing all up-to-date agriculture related information and statistics using diverse set of satellite, ground observation, and technologies. So this is mainly a operational center which is located in the IRI campus. So it is providing mainly information through Patel, which is called forecasting agriculture output using space, agrometeorology, and land observation. Under this, there are 4 programs are covered. One is a crop production statistic, which is called Patel. Then there is a NADMAS, there is National Agriculture Drought Assessment Monitoring System, and there is a Chaman, Coordinated Horticulture Crop Assessment. Then the 4th is a Kisan, Crop Insurance Scheme related project. So Mahalanobis National Crop Forecast Center is providing all information related to the drought, agriculture crop condition, crop yield estimation, crop area, and crop insurance, which are vital with respect to climate smart. As I said, these are the tools, remote sensing GIS, along with the crop model or climate model. All these 3 together forms a ideal tool for the early warning. And early warning is the basic needs for achieving climate smart agriculture. We need to inform farmer about what kind of this crop performance will be there, what kind of when drought will occur, and how much will be the impact on the crop. All need to be informed well in advance. So geographic informed crop model, which are software, inbuilt software to simulate behavior of plant as a function of environment and management condition. They have potential to assess impact of climate change, water use, and helps in formulating adaptation strategy. Because to achieve climate smart agriculture, one, you need to increase productivity, and second is the resilience or to develop adaptation strategy against climate change. So crop simulation model is one of the key to develop crop adaptation strategy or agronomic strategy against particular effect of the climate change. Similarly, for driving this simulation model, crop simulation model, one need to have a climate data. So how you can forecast in the advance? You need to generate a climate forecast, or you need to have a weather forecast in advance. So future climate or future weather pattern need to be generated with the global circulation model or regional climate model. So these are the models which generate or predict climate and study impact of this through downscaling approach. So this is one case study in Punjab where time lead time forecast, multiple lead times, where we have generated with up to 45 days in advance how best we can forecast the crop yield of wheat crop in Punjab and Haryana. So we could able to achieve accuracy with respect to 94 agreement up to 94%. Means 0.94 agreement is there. So with more and more representative, partially representative weather forecast, if included, assimilated in the weather crop simulation model, it is possibility to improve the crop forecast, crop yield forecast 40 days, 45 days in advance. Because here it is not, it is a partially representative weather forecast is there instead of point specific observatory data, which is used mainly used for the simulating crop yield at the district level. So similar concept can also be applied for generating drought decision and drought prediction and decision support, where climate model, crop model along with the soil moisture model can be integrated to generate soil moisture advisory service or irrigation and soil moisture advisory service. So here mainly there is a possibility of generation of the integrated drought index, remote sensing with the remote sensing meteorological indices, biophysical attribute. There is a one index already is there by US, that is vegetation drought response index. There is a evaporative stress index, which are mainly derived based on the geostationary satellite data. So here to generate drought forecast for the irrigation scheduling or planning to drought proofing techniques, we need to have some crop model or climate model, climate seasonal climate forecast along with the crop model to generate crop specific drought early warning. To generate crop specific drought early warning, you need to have a integration of all those remote sensing GIS along with the crop model, general climate model, and so on. The next topic that apart from this early warning, all those things, greenhouse gases, because we under climate smart agriculture we need to develop a kind of strategy that can help farmer to reduce greenhouse gases, so to mitigate climate change. The agriculture contributes around 10 to 12% of total greenhouse gas emission, but in India it is around 21% contribution is by agriculture. Out of this, 52% is contributed by livestock and 48% is contributed by agriculture. So here you can see livestock is one of the most important through, but it is a like that, we cannot avoid, we cannot reduce this emission because of this livestock. So it is for our livelihood. It is for livelihood, livestock emission, greenhouse emission due to livestock, that is for our livelihood. So that we cannot compromise, but at least we can improve carbon sequestration through growing of kind of crops, forest species, or grassland, which can sequester more carbon and reduce methane emission to the atmosphere. So for this, there are so many advanced techniques are there which can help you to quantify how much greenhouse gas emission is there, or what is the greenhouse methane flux or carbon dioxide flux. So we have also some kind of sophisticated eddy coverage tower that helps to monitor exchange of carbon between vegetation and atmosphere. So here we could able to do in the one sugarcane wheat system, which is high biomass, high carbon sequestration system. So here you can see more amount of almost more amount of carbon is being sequestered compared to the rice wheat system, where here in case of sugarcane wheat throughout the year there is a sequestration is there. All blue is telling, blue lines, that is telling uptake of carbon during the daytime almost for 9-month period. But in case of rice wheat, uptake of carbon is less. So sugarcane wheat based system, it is ideal for up to more sequestration of carbon, but at the same time we have to understand also contribution by irrigation and other things. So apart from this, okay, it is also generating large volume of data as a part of the big data ecosystem functioning. We can integrate remote sensing data, remote sensing derive daily weekly imagery either from Sentinel or Modis to compute gross primary productivity, which is a measure of total carbon fixation in the cropland system. So that we can also produce for different partially how much carbon is being fixed by the sugarcane wheat system. Similarly, we can also done net how much carbon is exchanged between vegetation and atmosphere, how much gross photosynthesis happening, how much carbon is released through ecosystem respiration. All can be monitored with the sophisticated flux tower, and flux tower observation can be integrated with remote sensing data to get the better picture about the greenhouse gas fluxes. Similarly, another tech that, okay, as I said earlier, agroforestry. Agroforestry is nothing but growing of agricultural crops together with the certain kind of forest plantation. So crop hedge means growing of poplar or eucalyptus on the boundary, that boundary and inside field growing of wheat crop, that is a crop hedge. Then there is another is a growing of mango along with the wheat crop, that is a agro horticulture. So there is a silvipastoral system also. There are many 7 to 8 kind of agroforestry system. So agroforestry is nothing but traditional land use adaptation. It may potentially support livelihood of the rural India by providing food, fodder and firewood, and also mitigation of the impact of climate. So agroforestry is one of the most traditional adaptation mechanism to reduce impact of climate change. So how? It can enhance biodiversity conservation, yield of goods, augmentation of carbon storage, and enhance soil fertility. So here you can see that world view data. You can see this all different field along with the boundary plantation. Somewhere you are seeing, okay, mango along with the this wheat crop. So we could able to classify the different kind of agroforestry system and map agroforestry system, so it can helpful for identifying the suitable sites of agroforestry, and agroforestry how it can help map agroforestry area to quantify contribution of this agroforestry on a regional level to support carbon storage and mitigate climate change. Similarly, as I said, we need to work on the water management. Now, water management is also important key adaptation strategy. By supplying irrigation, you can reduce the warming of the surface, you can reduce the temperature, and crop is cooled. Similarly, you can reduce the amount of energy used in the water withdrawal, water use. So finally, you can increase the efficiency of use of input, particularly water. So in particularly remote sensing data or earth observation data is useful for generating productivity of agriculture. It helps to achieve means better how best you can estimate productivity of the different crops, and also satellites like advanced sweep, sentinel and modis have ability to provide crop evapotranspiration rate, and which is finally again it is a denominator. Crop evapotranspiration, if you sum over the entire growing season, it will become water use. So using this productivity of particular crop and water use estimate from the satellite, you can generate water productivity or water use efficiency. So here you can see water productivity or water use efficiency of wheat crop ranging from 1.0 to 1.8. That means around 700 liter 700 to 800 liter of water is required to produce 1 kg of grain. So this is, if partially we get this kind of information, it helps to identify hotspot area of water use efficiency improvement, regional optimization of water saving practice, water harvesting or water pond. There's many structure. If you want to develop what are the water saving practice, mulching and many other agronomic techniques are there which are being used for saving water. So unless until farmer doesn't know what is the water use efficiency of their field, he cannot apply, okay, what kind of, whether he should go for certain micro irrigation system, or he should go apply certain kind of mulching technique, or he should go for certain different kind of irrigation system. So we should provide this kind of information which is vital for the farmer. Then precision agriculture, there are also all culmination of all this technology, beginning from weather forecast, smart sensor, drone, soil sensing, ground-based soil sensing, robotic agriculture, robots, and crowdsourcing as well as analytical techniques, all helpful to achieve precision agriculture, which is a technology that boosts productivity, efficiency of input, and preserve fragile environment. So there are many private industry which have shown tremendous interest to go for this kind of techniques and providing their services to monitor farm condition in real time basis for achieving better productivity and precise input of the precise application of the farm input. So like SetSure, 3 robotics, all are in operation to provide different kind of technology available to the farmer, so farmer can precisely improve his productivity as well as sustainability, conserve his farm. Similarly, another technique is a technological revolution is happening. Today, every third person is talking about the artificial intelligence, cloud computing, digital twin, robotics. So there are these all technology has got tremendous potential for the different sector, economic, energy, infrastructure, agriculture. Particularly with respect to climate smart agriculture, we are much interested how best we can make use of renewable source of energy, solar based, wind energy based infrastructure, and agriculture. Also how best we can predict yield, how best we can, okay, warn farmers about different impeding pest and disease, how best we can estimate water use. All technology require this technological innovation. So first stage, it is already, okay, we have achieved some operational achievement through satellite imagery, GIS and remote sensing and geographic database, and it has been now operationalized to achieve at certain scale of scale or level of information is available through different kind of portals and database server. Second stage is a cloud computing application, social media. Now all of we, so see, anything happen, everything is available on social media. So through social media, mobile application and cloud computing, now many things like COVID. Last time COVID also, it is all database, everything COVID, where is, how it is spread and what will happen in next, what are the medicine and so on. Everything was available through social media, cloud computing, and every information technocrat was working towards achieving better information for the public good. Third, that is, okay, going to third stage, that is going to revolutionize agriculture. So which comprising robotic, digital twin, big data analytics, blockchain technology, IoT sensing system, machine learning, and artificial intelligence. All this has got good potential to develop early warning system, predicting crop yield, developing disaster resilience, climate action, and so on. So tomorrow, after okay maybe okay for next 5 years there will be a large scale of application will be realized for the agriculture, where okay you cannot imagine that okay you can have a map in your mobile, yield map in your mobile 10 days in advance, or you may have okay what will be happen, what kind of drought signature, or where drought will hit, you may be having in your mobile within okay every field scale information will be there in the short span of time. Then also these days okay government of India is pushing drone digitalization of information agriculture. So under this there is a drone technology for digitizing land record, monitoring crop health condition, yield estimation for crop insurance, and so on. All activity, and for that there are more than okay so many, every state is having so many farm producing organization, and farm producing organization tying up with the private industry for drone based training to the farmers, and then farmers can use this drone for spraying of pesticides, for fertilizer, and so on. So there is a possibility that drone will be used, bring sea change the way we are cultivating our field, managing our field, and finally improving efficiency of nutrient, water, and energy. So here we can see this okay crop condition, mainly leaf area index condition, cotton crop yield map for particular one farm. It can be generated in the demonstration way, but tomorrow it will be a realized for every crop insurance activity, or every farm will be monitored by the drone to for the base smart irrigation, smart protection, and smart fertilization. These days okay large scale okay agro advisory is happening for the Gramin Krishi Mosam Seva, where geostationary satellite data like okay CCD and others today instead 3D and so on, which has been utilized for giving rainfall, what will be rainfall, what will be soil moisture condition for the suitability, and so on. So this particular agro advisory service, agromet advisory service, with the help of satellite will bring sea change and will bring huge gain and benefit for the farmers through national saving. There is a Kisan project like crop insurance using space technology and geoinformatics, where many pilot studies has been carried out with respect to the pest disease monitoring, hailstorm damage, white fly, then also heat waves, and also unseasonal rainfall and its impact, cyclone related damage, flood related damage, and crop loss in different states. Various activity has been carried out to assess crop loss assessment with the integration of GIS, GPS, smartphone, as well as drone, along with the crop cutting experiment carried out through okay more than okay 7,000 crop cutting experiment carried out annually across India, and all this is providing a larger picture of yield estimation and crop loss assessment for the different crops which are highly affected due to different extreme weather event, so they can be compensated with the crop compensation by the crop insurance companies. Many mobile application available for the crop cutting experiment and as well as hailstorm damage assessment. So early warning system globally, there are so many early warning system. One of the these crop monitoring, operational crop monitoring outlook is available through GeoGlam, global land agriculture land monitoring, GeoGlam. Then huge famine early warning system in Africa. Then Mars monitoring agriculture using remote sensing, global energy and water balance system, crop watch, crop explorer, and so on. These are the all worldwide different program and early warning system or crop growth monitoring system is there, which are providing global scale crop condition crop yield, crop productivity, and so on, which is useful for the targeting different intervention to support climate smart agriculture. Thank you all.